Hello everyone. In this video, we are going to find out the sum of n terms of any arithmetic progression. In order to do the same, let us understand the concept of average first. What is average? Though you may think that I'm going out of track, but just keep this in mind because we'll use it further down in our deduction of the n terms, summing up of n terms of any arithmetic progression. So what is an average? Suppose a set of data is given to us. Say a set of numerical data, we call it PQRS. It may represent anything, like it may represent the height of students of a particular class or the marks obtained in a particular subject, whatever. So if a set of data is given to us, how do we find the average of the data? That is one value which would represent all the values in this given set of data. We just add all the data, all the numbers in the data given to us. We sum all the terms in the data given to us and divide it by the number of terms. Let me call it n. So this is the average value of any data which is given to us. Now you just remember this. We will keep it aside and proceed with our finding the sum of n terms of an arithmetic progression. In the process, we may use this, right? We'll keep this aside. Now, consider an arithmetic progression with just two terms, a and b. So, how do you find the middle point of this a and b? Is there any way to find the middle point of this a and b? Now, look at that a and b as two numbers, and let's represent it in a number line for further clarity. So let this be a, let this be b. Now we have to arrive at a middle point of a and b. So if you call this point k, you have to arrive at one k which is equidistant from both a and b. That would be called the middle point or the mid value of a and b. So how would it be equidistant? If k minus a is equal to b minus k, this would be the distance from a to k, and from k to b, if it is equal, you can call k as the middle point of a and b, right? So how do we arrive at k? Just add k to both sides. Just add k to both sides. You get 2k is equal to a plus b, right? Or the midpoint of any two values would be a plus b by 2, right? Now let us consider four terms in an arithmetic progression. These were just two terms. If you consider four terms, 2, 4, 6, 8, this time I am considering numerical terms so that we don't have to go abstract. So now can we find the middle value of these two terms, of the middle two terms? How do we go about finding the middle value? Using this, a middle value k1 would be equal to 4 plus 6 by 2, right? Or 10 by 2. And can you find the middle value of 2 and 8, the first and the last term of this arithmetic progression? If I call it k2, it would be 2 plus 8 by 2, right? And this is also equal to 10 by 2. Why are they the same? Just look at it in a number line as before. Maybe you would get more clarity. So this is 2, 4, 6, 8. They are equidistant from one another because it's an arithmetic progression. You add plus 2 to each number, you get the second number. So the distance between any two numbers is going to be the same, right? Maybe this is one reason why the middle point of 6 and 4 and the middle point of 2 and 8 are the same, and they are equal to 10 by 2. Now, in this case, let's find the average of 2, 4, 6 and 8. The average. How do we find the average? We just saw that average was the sum of all, the sum of 2 plus 4 plus 6 plus 8 divided by the number of terms, which is 4, right? So can I just rearrange this average and write it as 2 plus 8 by 4 plus 4 plus 6 by 4. I haven't done anything much. I haven't altered the value at all. It's still equal. I've just added the first and the last term first and the fourth and the sixth term. The second and the n minus 2th term later. Right? And what do I get now? What is 2 plus 8 by 4? It is 10 by 4. And 4 plus 6 by 4 is also 10 by 4. So since the denominators are the same and it's equal to 4, I can write it as 20 by 4. But what is 20 by 4? If I divide by 2, both the numerator and the denominator, I get 10 by 2, which is the same as this 10 by 2, or the average of 2468 is the same as the midpoint of 4 and 6. That is also 10 by 2. The midpoint of 2 and 8. And the midpoint of 4 and 6 is also 10 by 2. So the average is equal to the middle point of the first and the last number of this arithmetic progression. And the average is also equal to the middle point of the second and the last but one number in this arithmetic progression. Right? So what have we now arrived at looking at all this? We have arrived at the middle point of A and B is A plus B by 2. This is number 1. And if you consider this 2, 4, 6, 8, this sequence, arithmetic progression, the average of all the 4 numbers was equal to the middle point of the first term. Can I write it as, middle point of first term and last term, right? Also equal to the midpoint of the second term and n minus 2th term. So all this we just saw now. Now try to apply this for a number for an arithmetic progression with 5 terms. Consider the multiples of 6, 0, 6, 12, 24. Am I right? No, I'm 18 should be there after 12, right? So 0, 6, 12, 18, 24. So consider this term. Why don't you try, you just take your pen and paper out and try to find the middle term of 0 and 24. Place it in a number line if you want further clarity. Try to find the middle point of 6 and 18, the second and the n minus 2th term, and even the midpoint of 12, the third and the n minus 3th term. You would find that if you have worked out, please pause the video and work out, you would find that all the middle points are the same. And you would also find that the average of all these numbers added by 5 would also be equal to those middle points. Just try and just find out and see if it is right. So now what is our deduction? Our deduction is, since average is equal to sum of all terms by n, if by some means we can find the average, the means we have found just now, if you can find the average, then it's very easy to find the sum of all terms, right? You can just say sum is equal to n into average, where n represents the number of terms. My average spelling is wrong, right? Sum is equal to n multiplied by average. This is a deduction from here, which we saw before. Right? So far it's okay, isn't it? You're able to understand. Now, consider a general arithmetic progression. What is a general arithmetic progression? The first term is A. The second term is A plus the common difference. The third term is A plus 2 times the common difference. D plus D, you're adding one more D. And so on till the very last term would be A plus n minus 1 into D. Isn't it? So this is a general representation of an arithmetic progression. So now what have we seen? We have seen that the average of all these terms added and the terms added divided by n is equal to the middle point of the first and the last term. It is also equal to the middle point of A plus D, and you can call this A plus n minus 2 into D, isn't it? So this is what we have seen so far, right? So can I write the average of this is equal to a plus n minus 1 into d by 2, isn't it? But we saw that the sum of all terms is equal to n times the average, right? So from here I can say the sum of all terms in this AP is equal to n times average, which is n times this whole thing. I'll just add up the a's. There are two a's, so n times 2a plus n minus 1 into d by 2, right? Or if I take the 2, I can rewrite it in very much a simple way as n by 2 into 2a plus n minus 1 into d, right? I'll just rewrite it. 2a plus n minus 1d. It's the same. I've just rewritten it by factoring the 2 out, by distributing the 2. The 2 can be, the half can be distributed now to arrive at the same equation as before, right? So this is the sum of n terms, and this is what we derived in our earlier video also. In fact, we didn't derive there. We just saw that, manipulated a few steps and arrived at this n by 2 into 2a plus n minus 1d. So this is our sum. So in this video, we have also found another way of expressing the sum, because average was equal to the middle point of the first and last term also. We can say this average can also be expressed as a plus, this is the last term, right? A plus last term by 2, or I can rewrite this as sum is equal to n into last a plus the last term, if I call it L by 2. So let me write it clearly, n into first term plus last term by 2, or n by 2 into first term plus last term, n by 2 into a plus L, right? So now, even if we do not know all the d, etc., the common difference, we can still arrive at the sum of an arithmetic progression using n by 2 into a plus L, right? I hope you have understood and you have followed this video. Thank you.